The product that we want to do the innovation is magnetic blender. The blender with a focus on an innovative design that uses a high-speed motor powered by a magnetic coupling instead of a traditional physical connector. This improvement makes the appliance quicker, safer, and more energy efficient with the added benefit of battery operation. The innovation strongly relates to the topic of rotational motion as it involves angular velocity, torque, and rotational kinetic energy in the operation of the blade. Additionally, it touched on thermal physics and thermodynamics through energy transfer, heat generation, and efficiency. By analyzing this device, we can better understand how physics principles apply to real-world technology and how small design change can lead to significant functional improvement.
Assalamualaikum warahmatullahi wabarakatuh. So the main issues that we are solving is actually pretty common, which is traditional blender are way too noisy and they can be unsafe because of direct contact between moving parts. They also waste a lot of energy through friction and heat. So in this study case, our innovation is to replace the physical connection with a magnetic coupling system. They make it quieter, safer, and more efficient. This is because there is less friction and less heat loss. This directly related to what we learned, like rotational motion and thermodynamic, where we study how friction and heat affect energy efficiency. So who do you think that need this blender? So the people who need this is most are those who use blender frequently. For example, at home might use it every morning for smoothies or baby food. And in business like selling juice, blender are used all day. This user face constant issues with noise, overheating, and breakdowns. So a safer, quieter, and more energy efficient blender really helps.
Okay, so right now I will explain to you guys about how often do people experience these problems and when about electrical blenders. So for the first point, electrical blenders make such a loud noise. Traditional motors and drive system are often noisy, so it could disturb people around it while we're doing the task. So for the family who have a baby, traditional blender could become a problem because the loud noise could disturb the baby's slumber. For the second point is the energy consumption problems. Traditional blenders can be inconvenient because the power is limited. While using the traditional blenders, we need a power outlet to perform the task. It becomes inconvenience for those who wants to travel afar or who wants to make a smoothie in a hurry. So for the third point is the blade exposed. Electrical blender blades are often fixed or difficult to detach. So while cleaning, the blades are exposed and it can become dangerous towards students because they could injure themselves. So right now for this slide, we will discuss about how big is the problems of using the electrical blenders for users or customers. So for the first problems are the frequent malfunction. Frequent malfunctions of traditional blenders can lead to frustration and inconvenience for users. When blenders stop working properly, especially during food preparation, it disturbs daily routines and forces customers to spend extra time and money on repairs or replacement of the new blender. For the second point, it's about unwanted costs arise when low quality or outdated blenders break down easily. In this situation, users often have to purchase spare parts or entirely new units more frequently than usual. This can be a significant burden, particularly for households on a tight budget or small food business relying on consistent performance. Okay, for the last problem, the inefficient blending performance is a common issue in traditional blenders. Poor motor quality or dull blades leads to uneven blending, require longer time processing, and repeated attempts. This not only wastes electricity, but also impacts the texture of the quality of foods, which can be crucial for both home cooks and small-scale food vendors.
If the need for innovation in blender design is not met, firstly, traditional blenders rely on physical connector, which create high friction and result in energy loss of heat. This not only lower efficiency, but also causes overheating, reducing the lifespan of the motor. Secondly, without noise reduction improvement, these blenders remain loud and disruptive, making them unsuitable for quiet environments such as early morning or shared space. In terms of safety, exposed or poorly insulated mechanical parts increase the risk of injury or malfunction during use. Additionally, without portable or battery power option, users are limited to power outlet, reducing flexibility and convenience in mobile or hotel setting. Over time, inefficient energy usage may lead to higher electricity costs and greater environmental impact. Lastly, failure to meet modern user need may cause the product to fall behind competitors, resulting in lower customer satisfaction and reduced market demand.
Our unique approach is to design a magnetic blender based on using rotational motion and thermal physics concepts to improve how the blender works. Instead of using traditional mechanical parts like gears or shaft, this blender uses magnetic coupling, a system where magnets transfer the spinning force from the motor to the blades without any direct contact. This makes the design smoother, safer, and more efficient. From a rotational motion perspective, we focus on how the spinning force or torque is applied and how the blades respond, how fast they spin, how they accelerate or slow down, and how their shape and weight affect their movement. It's about making sure their motion is stable and controlled for better blending. At the same time, we use thermal physics concept to study how heat is generated inside the motor. Even without friction, there's still heat from electrical currents and magnetic effects. We look at how this heat moves through the system and how to keep the motor cool so it stays safe and runs efficiently. By combining these two concepts of physics, we're creating a blender that doesn't just work, it works better. It's quieter, more energy efficient, safer, and designed for modern use including portable, battery-powered models. Broadly speaking, our solution is a blender powered by a magnetically coupled high-speed motor designed for optimal performance through precise control of rotational motion and improved thermal management. By removing traditional mechanical shaft and using rotating magnetic fields to spin the blades, the system enhances both mechanical and thermal efficiency. Our design offers tons of benefits such as greater safety with no exposed rotating components, higher energy efficiency by reducing both frictional losses and heat generation, better torque control and smoother, more stable angular acceleration, quieter operation due to the absence of direct mechanical contact, effective thermal regulation as reduced friction minimizes excess heat and remaining heat can be efficiently dissipated via conduction and convection, and lastly, battery compatibility which supports intelligent control over both rotation speed and heat buildup. This solution applies core principles of rotational motion, including angular velocity, torque, and conservation of angular momentum to achieve consistent controlled spinning of the blades. At the same time, thermal physics concepts such as heat transfer, specific heat, and energy conservation are used to prevent overheating and maintain system efficiency. By minimizing energy losses through friction and excess heat, more of the motor's power is directed toward useful work, which is spinning the blades efficiently. And by keeping the motor's temperature within optimal limits, the system avoids thermal damage, ensuring longer lifespan, better reliability, and sustainable energy use. This integrated physics-based approach turns a common household device into a smarter, safer, and more efficient appliance.
Assalamualaikum and hi. So first of all, let's talk about the magnetic strength and torque transfer. Since our blender doesn't use a physical connection, the magnetic coupling must be strong enough to transfer high torque from the motor to the blade. But the challenge is standard magnets may slip or lose alignment when the blender runs at high speed or under heavy resistance, especially when we are blending a hard ingredient such as ice or nut. So in order to fix this issue, we're gonna use a high-grade RAM and magnets such as neodymium and arrange them in a way that maximizes the magnetic field strength and efficiency. This is believed to help to maintain a strong, stable rotation even at high speed. Point number 2 is heat management, where high-speed motors generate heat. But if there's no direct connection, the heat cannot escape through the usual metal shaft, and this will cause overheating that may damage the motor or cause safety risks. So the solution that I would like to propose is to add internal cooling system or heat sinks to help remove the heat and to keep the motor temperature safe. Lastly, point number 3 is material compatibility and safety. So the issue is strong magnets near electronic components can interfere with circuit or attract unwanted metal particles, and this can be dangerous, especially in a kitchen environment. But the main challenge is how can we keep the product that we're gonna use is safe and food grade. My solution is to use a non-conductive shielding materials and design to isolate magnets from sensitive components. So this will keep the electronics safe, and we can also prevent any unwanted magnetic interference. So lastly, we can conclude that our innovative magnetic blender design introduced a high-speed motor powered by magnetic coupling instead of the usual traditional physical connectors. And also, our design offers a modern, safer and more durable for both home and commercial users. That's all. Thank you.